Let's work on section 7.4. So again, a little math humor. The 6 most confusing words in statistics failed to reject the null hypothesis. Triple negative. All right, so this section is going to work the same way as 7.2 and 7.4 as far as setting up hypothesis testing, but this time we're going to use proportion stats because we're going to have proportions, but everything else will work the same way. Let's take a look at the different items we need. We're going to be using a z-test. If we have to find a critical value, we're going to do the normal calculator, the z again. We do have to test, just like we did in chapter 6. We're going to test to make sure that n times p is greater than 5 and n times q is greater than 5. We'll look at that in a few minutes. Everything else will work the same. We're going to have rejection regions. We're going to have a critical value versus a test statistic. We've got the p-values. It's just that we're going to be in proportion stat. All right, let's look at a problem. So the researcher claims that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. So our claim is that P is less than 0.45. Now, since it's less than and not less than or equal to, we're going to put that in our alternative hypothesis. So P less than 0.5 is going to be our alternative hypothesis. That's also the claim. Our null hypothesis, H naught, is going to be the complement. So that's going to be greater than or equal to 0.45. All right, let's see what else they told us. In a random sample of 100 adults, so n is equal to 100, 41% say they use passwords that are less secure because complicated ones are too hard to remember. So that means that our p hat is going to be 0.41, and that tells us that q hat, remember q hat is 1 minus p hat, and so q hat is 0.59. All right, so let's go ahead and test real quick. We are going to take n times p hat. That gives me 100 times 0.41, which is 41 successes. That's greater than 5. And then we're going to take n times q. So that would be 100 times 0.59, and that gives us 59 failures, but that's still greater than 5. Okay. Okay, so we know we have a left tail test, and that's because our alternative hypothesis is less than. We're going to go to the left. Our alpha is 0.01, and so that's the area here in our tail. So we're going to go to calculator normal. We're going to do less than or equal to and put our alpha in the area box, which is on the right. When we do that, we get our critical value. So our critical value for this problem is negative 2.33. Okay, so area in the right-hand box like we've been doing, and a less than sign because we have a left tail. All right, now we're going to go into proportion stat, one sample with summary. We're going to put in what we know. We're going to put our number of successes, that was 41, our sample size of 100. We're going to set up our hypothesis test with 0.45 and the alternative being less than or equal to, or less than, excuse me. Then we hit compute. We get our p-value of 0.2107, and we get our test statistic here of negative 0.80. So remember, that is our test statistic. So now we have two different ways to see if we're going to reject or fail to reject. If we just look at our graph, well, the first thing we did was we knew our alpha was 0.1, and so we found our critical value. Our critical value is negative 2.33. That is the mark here for our rejection region. So then we need to look at our test statistic. Well, our test statistic was negative 0.80. Well, that's all the way over here. that is not in the rejection area. It is outside of the rejection area. Therefore, we are going to fail to reject the null hypothesis. Now, we could have done the same thing with the p-value. When we put it into StatCrunch, our p-value was 0.2107, and we have to compare that with our alpha, which is 0.01. Well, that p is huge. It's 21%. That's a lot. And since it's greater than alpha, we are going to fail to reject. Now, where we have to be careful is our claim was in the alternative. So since we failed to reject the null hypothesis, we cannot support the claim. It's one or the other. We either have to, in order to support the claim, we would have had to reject the null hypothesis. So in this case, we're going to fail to reject the null hypothesis, and therefore we cannot support our claim, which is the alternative. This page is just to show you where we went. We went to proportion stats, one sample with summary. We put in what we knew, and out popped our test statistic and our p-value. Okay, let's try one more. A researcher claims that 51% of US adults believe incorrectly that antibiotics are effective against viruses. So the claim is that 51% believe that antibiotics are effective against viruses. And so that means that p equals 0.51 is going to be our null hypothesis because it has an equal sign. Our alternative will be not equal to the 0.51, and our claim is the null. Now let's see what else they gave us. They told us that we looked at a random sample of 2,202 people. That's our N. That 1,161 of them believe antibiotics work against viruses. So that's our number of successes. And then finally, our alpha is 10%, 0.10. Okay, so if we go ahead and put all that into proportion stat, I get a p-value of 0.1054. So I'm comparing my p-value of over 10% to my alpha of 10%. Therefore, it's greater than, and so I'm going to fail to reject the null hypothesis. Now, we always have to go back and see, once we decide if we're going to fail or reject, we have to see where our claim is. Well, this time our claim is the null hypothesis. So when we fail to reject the null hypothesis, we actually support the claim because the claim is the null hypothesis. If we had rejected the null hypothesis, then we would not be able to support the claim. Down here in the corner is just looking at this if we wanted to look at rejection regions. If we had found our our critical values, our rejection regions are on either side of 1.645 and negative 1.645. But our test statistic from up here, I must have had round off error here, but they've got it at 1.60. So it's on the right-hand side of the rejection region, and therefore we're going to fail to reject. But we already saw that in the p-value. Remember, it's one or the other. Either check the p-value or check the test statistic. Okay, I'm going to walk you through one more. This says that the claim is p is not equal to 0.25. So the claim is here in the alternative because it's not equal to. The complement is equal to, that's my null hypothesis. My alpha is 1%. For the sample, I talked to 200 people, and my p-hat was 0.23. Okay. If I want to check NP and NQ, I'm good to go. Both of them are greater than or equal to 5, and that's why I was able to answer back here. So remember, Q is always 1 minus P, and therefore Q is 0.77. But both of them gave me a value greater than 5. All right, then I put everything into my proportion stats. And when I do that, I get a p-value. I get a huge p-value. Look at that, 51%. And I get a test statistic. And so I can answer either way. They actually asked for my test statistic here. And so I'm going to put this negative 0.65 into the box. But then if I want to just look at p-value, I can. It doesn't matter which one we look at. So the p-value is 0.5136. It's huge compared to the 0.01. And since the p-value is greater than the alpha, I'm going to fail to reject H naught. The issue is I have to look at where my claim is. Well, my claim was the alternative. So what happened in this case is I failed to reject the null hypothesis. Excuse me. And since I failed to reject the null hypothesis, I cannot support my claim because my claim is here. So it's one or the other. If I had rejected H naught, then I could support the claim. But since I failed to reject it, I cannot support the claim. And so I'm going to say that I do not have enough evidence to support the claim.